Okay, cabbages, page 94, whatever it was for you. 96. That is my fourth favorite font. FontDiner.com sparkly. Please mark your work. Every question is out of 2. Use your own judgment. Amazingly, everyone is going to get 18 or 19 out of 20, and then I'm going to give you a test on this, and you're going to get like 8. But, you know. I always find it amazing when you guys mark your own work. You're either as cruel as possible, or you're like, oh yeah, that's right, sure, full marks. It usually depends on if I get you to trade papers or not. If I get you to trade papers, you guys mark each other's work with a razor blade. You're horrible to each other. Way meaner than I ever would be. That's why I've stopped getting kids to trade papers. Because I would get them to trade papers, kids would mark them, the kids would get them back. What? I got 1 out of 80? And then I'd have to remark it anyway, right? Shouldn't I get something here? I'm like, yeah, you can have something there. That's why I went to you marking your own work. And for a few years it worked, but now it's 20 out of 20, 20 out of 20, 20 out of 20, 20 out of 20. Here's the test, 3. But, oh yeah, it's the stress. Right, because it's very stressful when you do something for the billionth time, right? I sometimes get nervous when someone says, take a deep breath. Holy crap, I forgot how. Take a deep breath. Or when you run a race, you're being assessed all of a sudden. Ready, set, go. I don't know. Yeah, okay. Any questions about number 1? Ask them now because we're moving forward. Because if you guys are anything like the first block, I'm going to need a lot of time today. Oh, you'll hear. All right, number 1, everyone's good? Number 2, everyone knows the difference between exact and approximate, yes? Exact and approximate. I wanted both. That's why I asked for both. It's kind of like when you go to Subway and you want, a tuna sub. You go in and you ask for it. Yeah, it probably should be -3. And there are the next ones. I will accept either 2 equal roots or 1 root. There. What vessel has my drink in it right now? Water. It's a drinking vessel. Everybody knows that. If you are writing down the right answers, do not give yourself 0 and get them from the video later because I need the time today. Today's concept I thought was beyond easy, but apparently it wasn't. So, best method possible. What is wrong with that instruction? Who decides what the best method is? You do. So if you wanted to expand this and use the quadratic formula, that's okay. You'll still get the same answers. I, of course, would never do that because that's a crap ton more work. Because as soon as you hear the quadratic formula works every time, what? Every question's out of 2. You're going to end up doing 10 questions. Everything's out of 2. There is the next page. No roots and plus or minus 2. There's the next one. -1 and -4 plus or minus root 7. And there's the end. Now, ladies and gentlemen, did I need the number line here? No, because there weren't any options. I was just less than 8/3. So I'm okay. When I need the number line is when I have options, right? Because then I gotta check the number line to find out where the answer actually lives, okay? But when there's just one value there, if I've done my algebra right, then the line can only go in one direction, right? I showed you checking with 0 just to make sure you understand what I am doing there, yeah? All right, everybody good? Making the whole thing out of 20. Record it. I'll get it from you later. I was planning to get it today from the other class, but there was trouble. For what? 4 has A, B, C, D. What letter do you want? The answer is -3/2 and 4. All good? All good? All right. Please, wrong page. That is your work, but please go to page 98. Okay. I need a deep cleansing breath. Are you going to review my breath? Oh no! Anxiety! I'm being assessed! All right. Ladies and gentlemen, before I go forward, I need to make sure of something. And it's sad that I need to do it, but I need to. What is the simplest line that I can graph that uses 2 variables? A straight line, but I need 2 variables. What is it? X equals Y, right? Don't write this down. When X is 1, what's Y? 1. When X is 3, what's Y? 3. When X is -3, what's Y? So, 1, 1, 2, 3, 1, 2, 3, -3, and positive, right? Zoom, right? Okay. Every other line you have ever graphed in this class is some form of that, isn't it? If it was y equals 2x, all of a sudden, instead of going over 1 and up 1, I'm going over 1 and up 2, aren't I? And now my slope is 2. And it looks like that, yes? If it was 1/2 x, it would be over 1 up a half over 2 up 1. It would look like that green one, yes? If it was 2x minus 4, this red line would drop down 4 to here, yes? Every line you draw is a variation of that. Everyone agrees? Everyone understands the logic there? Okay, now we move forward. A quadratic function, every single quadratic function is a variation of the original quadratic function, y equals x squared. Everything else is a variation of that. Now, if I wanted you to put this on a graph and we were pretending we knew nothing about parabolas and knew nothing about graphing, you would all, I hope, make a table of values. Right? Some of you call them T-charts. I do not. Get used to it. If you were going to make a line, and you were in my class in the 10th grade, how many points did I say you had to have? 3. Because once you have 3, you can make a straight line. Because if you only have 2, the third one could be way off somewhere else. Yes? Okay. In parabolas or quadratic functions, we need... Sad joke. No. Say your number. We need 5. Now, parabolas deal with positives and negative numbers, yes? So we are going to use 5 numbers. Are they going to be x's or y's? X's, because that is the independent variable and that is the input. We choose the input. We are going to use the 5 easiest numbers to work with. What are they? I need some negatives. -2, -1, 0, 1, 2. Everybody cool? When x is -2, what is y? 4, yay. When x is -1, what is y? Yay. When x is 0, what is y? When x is 1, what is y? When x is 2, what is y? 4. And then we graph it. Now, we start at 0, 0. Yeah? What's the next point I need? 1, 1. Agreed? And 2, 4. Yes? 1, 1, 2, 4. What are the other 2 points? -1, 1 and -2, 4. Please tell me you see a few different patterns. Now listen, there's no wrong answer right now, so I should hear some people speaking. The only reason I should hear nothing right now is if you can't see any patterns here. If you can't see patterns here, I am concerned. Please, one of the 30 of you, tell me something that looks like it might be a repeating pattern. Preston? It is symmetrical. Indeed it is. Anything that happens on the right is reflected on the left. Well done. Would anybody like to see if they can see another pattern? It's okay. It's okay if you don't. You got 1. You're already infinitely better than the previous block. Well, because they found no patterns. And 1 is infinitely more than 0. Henry. The y value increases in both directions? What do you mean? Yes, the y value continues to go up. That is the beginning of the pattern that I am seeking. How far does it go up here? 1. How far does it go up here? 4. How far did it go here? 1. How far did it go here? 2. What's the relationship between 1 and 1, 2 and 4? What do you think it's going to be if I went 3? 9. Why? So what if I go out x? How far up will I go? X squared. Brilliant. So, from the vertex, Where is the vertex? Where the parabola turns. From the vertex, every parabola, if it's in this regular form, from the vertex, if I move left or right, x, I move up and down, x squared. Does everyone understand? So, right now I'm at 0, 0, yes? What will be the address of the point on the parabola that has a x value of 6? 36, because I moved 6 horizontally, so I moved 6 squared vertically. Is everybody good? Complex, hey? Or super unbelievably simple? Exactly. Let's move on. We are going to discuss all of these things with a basic quadratic function. The vertex, we've already talked about that. It's the turning point. Right? It's where the parabola reverses. That's all I'm going to say about it. In this, it is 0, 0 on this line, yes? Everybody's cool? The vertex always has an x and a y value. Always. Because the vertex is always a point on the coordinate grid. Right? And every point on the coordinate grid has an x value and a y value. Everybody's good? Now, the axis of symmetry. My good friend Preston noticed that right through the middle of the parabola is a line, an imaginary line, that it is exactly the same on both sides, yes? Except what has reversed? The what? The signs of the x value, yes? So the equation of the axis of symmetry is the imaginary line. That's the axis of symmetry. The imaginary line through the middle. The equation of that line is x equals, because it's a vertical line, so it's x only, x equals whatever the vertex is, the vertex x. So in this case, the vertex was 0, 0. So what's the axis of symmetry? X equals 0. Everybody cool? Because it's an axis of symmetry, it is exactly the same on both sides. So if I have a dot on the graph at 7, 18, what will be on the other side of the axis of symmetry? Negative 7, 18. Everybody good? Sweet. The x-intercepts, those are x comma 0. We call them the zeros. We have also called them the roots. Right? Most parabolas will, or all parabolas will have one of 3 options. What are the choices? You just did a whole day on this. 2 roots? No roots? Or 2 equal roots, which appears as 1. You'll have 0, 1, or 2. How many roots does this current parabola have? 1. And what is it? 0, 0. It also happens to be the vertex. Everybody cool? Why have I written 0, 0? Because an x-intercept is an x value and a y value. Every single y value of an x-intercept is what? 0. Good. What is the y-intercept? 0y. And that is when the parabola does what? What does it cross? The y-axis. How many can a parabola have? 1. And only 1 in our situation. What do I mean by that? Eventually you will do parabolas that look like this. Don't write this down. Right now, all our parabolas look like this, yeah? That's y equals x squared with some math, because it's moved away, right? But we can have parabolas that do that. That is x equals y squared. Now there's 2x, 2 y-intercepts, but only one x-intercept. Ho, 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 ho. But you don't have to worry about that because we don't do that in grade 11. Okay, no, they'll not make a circle because they're parabolas. No. They still won't be a circle. They will make an ellipse. They'll make lips? Okay, stop. We're getting off topic. Our parabolas have how many y-intercepts? 1 and 1 only. Will it always have a y-intercept? Yes, always. If we're graphing a parabola. What if we're graphing a real-life situation that uses a parabolic line? Is it necessarily going to have a y-intercept? No, because the parabola is all the way through the universe, yes? But in reality, a lot of parabolas aren't going to have negatives. Everybody cool? Sweet. What is the domain? You have to think back to grade 8, or grade 10, I mean. The domain are the x values, yes? So let's look at our parabola. What's going to happen as it goes way up here? What is happening? It gets steeper, but what is happening to its... I don't care about the steepness right now. I'm talking about domain. Domain are the x's. What's the biggest number I can put in for x? What's the biggest number I can put in for x? Infinity. What's the smallest number I can put in for x? Negative infinity. So the domain of every parabola is what? Every single number ever. X is a set of real numbers. Of the parabola, is that in real life? No, of course not, because anything we would measure wouldn't actually go to infinity, would it? Right? If we were talking about time to boil water or something, we're not going to boil water until infinity, are we? Right? Everybody's cool? That was a lot of time. Well, they say a watched pot never boils, Mr. Meyer, so I guess you would boil it till infinity. What is the range? The range is trickier. If domain are the x values, what is the range? Y values. Now, look at our parabola. What limits the y values? Starts with a V, ends with an X, has Urtet in the middle of it. The vertex. The y values are limited by the vertex because it turns back on itself. This one can't go lower than 0. So y, all my y values are what? Bigger or smaller? Greater than or equal to 0. What if my parabola did this? Now what are my y values? less than or equal to 0, right? What if my parabola did this? And that was 6. Y is less than or equal to 6. And what if my parabola did this? That was A comma B. What's my range there? Y greater than or equal to B. And B just so happens to be the y coordinate of what? What is that point on this? The vertex. So y is always greater than or equal to, less than or equal to, greater than or less than of the y coordinate of what? I forgot an O there. That just says coordinate. Well, the y coordinate of what? The vertex. Is everybody cool? All right, now let's start applying this. Turn over the page. We are not going to use graphing calculators because we're not wusses. Right here, please notice you see y equals x squared, don't you? Right? So that tells us that even though our parabolas can end up looking this crazy, how do they start? Y equals x squared. Everybody cool? We've already done y equals x squared, so let's graph it. I put a dot at 0, 0. When I go over 1, how far up? 1, because I go up the square of how far I go left. When I go over, or right. How far when I go left? I go up 1. How do I know I've got 1, 1? How do I automatically know that's negative 1, 1? Because there's a line of symmetry there, right? Just the x value flips. The y stays the same. What's the second point? Because I need 5. 2, 4. So what's this point over here? Negative 2, 4. Everybody good? Please notice, these are how far apart? 2, because it's 1 from each side of the symmetry line, right? How far apart are these? 4, right? Everybody good? And then I would draw my line. That's the basic one, yes? Everyone agree? All right, now, look at this next one. I've added a 3. That's the P, right? Right? Okay. Since I've added something new, and I'm asking you to graph it, and I haven't taught you any tricks, the only option we have to graph this bad boy is to make a table of values, correct? Let's do it. X, Y. Negative 2, negative 1, 0, 1, 2, negative... Oh, sorry. What are my y values? What's negative 2 plus 3? What's 1 squared? 1. What's negative 1 plus 3? What's 2 squared? 4. What's 0 plus 3? What's 3 squared? What's 1 plus 3? What's 4 squared? What's 2 plus 3? What's 5 squared? Something weird's happening, yes? What's happening that's weird? I keep going up, don't I? So have I even hit my vertex? No, because I'm only going upwards. Is my vertex going to be right or left of negative 2? Left, because as I go to the right, I keep going up, yeah? So I better choose a number that's left of negative 2. What would that be? Negative 3. What's negative 3 plus 3? What's 0 squared? There's my vertex, because that's my x-intercept. Everybody cool? All right, so let's put it on there. Negative 3, 0, yeah? Everyone agree? Okay, well, I know I'm at negative 2, 1, so I go to negative 2 and I go up 1. Hey, I went 1, 1. Interesting. What happens to the right? What's this point going to be? Negative 4, 1. I am doing that because I have a reason. What's the next point going to be? It's on the graph. Negative 1, 4. It's on the table of values. What's this one going to be? This is negative 1, 4. What's this one going to be? Minus 5, 4. Yeah. All right. And that makes this line, yes? Right? Now look. It's the same parabola, isn't it? Except what has happened to the vertex? It moved where? 3 to the left. What do you see right there? 3. What do you see right there? Negative. What does a negative sign mean? It means, what are some things negatives, the sign, that sign, what are some things it means in math? Subtraction. Left. Less than 0. Down. Take away. Opposite. All those things, yes? What applies here? I see a plus 3, but I moved it negative 3. Because here it says minus, but here it says plus, and I moved it to the left. What does that negative sign mean in this case? Starts with an O. Opposite. This is my X adjust. No, I'm not going to say X. Yeah, I am. My X adjustment for the vertex. And what's the trick we have to remember? That negative means it's opposite, because it's telling me to do the opposite of what P is. So this is plus 3, so I have to move it negative 3. Is everybody cool? Now, using your knowledge that you have, how can you graph this one? Where will this one move? To the right 2. So what is my new vertex? 2, 0. When I move 1 to the right, how far up will I go? 1. What is this point? 3, 1. What is this point? 1, 1. What is this point? What's this one? 4. Four, 4. What's this point? Zero, 4, actually, of course. It should have been there. 0, 4. Everybody good? Notice, again, it's the same parabola. It's just shifted 2 to the right. Okay. What letter is that one? Because it's not P anymore, is it? That one's Q. It's new, right? So we had better do a table of values, right? Or do we need to? Remember, every parabola starts from that, yeah? So that vertex is 0, 0, correct? What are we going to do now? It's going to go where, Henry? Down how far? 4. Because 0, 0, but now I'm taking away 4 from that result, aren't I? So this is vertex going to go down to 0, negative 4. Right? So what is going to happen to all the other points from here? They're going to drop 4, aren't they? So rather than being 1, 1, what is it going to be? 1, negative 3. And then what's this one going to be? Yeah, negative 1, negative 3. What's this one going to be? When I go over 2. 2, 0. What's this one going to be? Negative 2, 0. Q is our Y adjustment for the vertex. But is it opposite? No, because it says plus. So for this one, we do what we see. Actually, Henry, it doesn't. It doesn't get any harder. But you would have... Oh, you should watch the video for the other class today. Okay, now, ladies and gentlemen, what is happening here? We're going to do this one together. I should start right there, but I'm not starting there. Where am I going? 2 to the right and up 5. So what is my vertex now? 2, 5. When I move 1 to the right, what is my x value? 3, you can count. Good. When I move up 1, what is my y value? 6. 3, 6. What does that automatically make this one? 1, 6. When I move 2 to the right, what is my x value? When I go up, how far do I go up when I move 2 to the right? 4. So I'm at 4, 9. What is this one? Automatically. 0, what? 9. And I'm done. Is everybody cool? You try this one, because it's exactly the same concept, but the directions are different. Go. I will hold the phone, because I love that old-timey saying. What's next? What's next, fellas? We can all talk in an old-timey voice and go swimming in those fun costumes. Hold the phone, Priya. You're the cat's meow. You're the bee's knees. Really? All right. What is the vertex? What is the first point to the right of that? -1, 4. What is the first point to the left? -3, 4. What is the next point to the right? 0, 7. What is this point? Automatically. -4, 7. Because I got to go 4 away and I keep it the same height. Is everybody good? All right. Now, what's different in the next one? There's a negative out in front, yes? And that is in the position of A, right? Now, you're smart kids. Has there been a negative in front of any of the parabolas we've drawn? No. And all the parabolas have looked exactly the same, yes? What do you think is going to happen? It is going to go down. Now, all teachers I have ever had have done the same thing right here. They have said that it's a negative parabola, so it's feeling negative, so it's feeling down. So it's a sad parabola, which is why I drew it in blue. Now, that's not my joke. Some kid from the other class, I was drawing in another color, and the kid was like, well, shouldn't it be blue? And I was like, oh, so I stole it. So you know that I don't usually do those stupid little nicknamey things, right? But I'm running out of time. You're finishing high school soon. I gotta cave and do some of those little nicknamey things. So a negative A, negative A equals sad parabola. Positive A equals happy parabola. Okay? So, since the only thing that is changing is the happiness or sadness, what is the vertex here? Because that looks an awful lot like that one, doesn't it? So what's the vertex? 0, 0. But instead of going right 1 and up 1, where am I going? Right 1 and down 1. So what's that first point? 1, negative 1. What is this point automatically? Negative 1, negative 1. What's the next point? What's this point automatically? And now I get a sad parabola. Okay. All right, now, ladies and gentlemen, now I am asking once again to put it all together. What is the vertex here? Five, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 5, 6. Right? Okay. Where is my first point to the right of 5 going to be? Right and down. 6, 5. What is this point automatically? 2 away makes it 4 and the same y value. What's the next point? 7. 7, 2. This point must be 4 away from 7, so it is 3. And what's the y value? 2, because the y values don't change in sad parabola. Is everybody good? Everyone is good? Okay. Oh my good gravy, what's happening here? A is now a number. Is A positive? So is it a happy or a sad parabola? Happy. Now, what's going to happen? If there was no 2 there, I would go over 1 and up how far? 1. Or, more useful, I would go over x and up how far? X squared. Right? But now, what's happening? What is happening to x? It's doubled. So I don't go over x and up x squared. I go over x and up 2x squared. What if it was ax squared here? I would go over x and up how far? Ax squared. Everybody understand? Okay. So logically, if there's no 2 there, what's my vertex? 0, 0. Normally, I'd go over 1, up 1. Over x, up x squared, yes? But I'm not doing that. What am I doing this time? Over 1 and up 2 times x squared. What's x squared? 1 times 2. So what's my first point here? 1, 2. What's this point right here? -1, 2. If I go over 2, how far do I go up? It's 8. Oh, he's saying A. That was wicked. Why is it 8? Because 2 squared is 4, and then I times it by 2. So what's my next point? 2 what? 2, 8. So automatically, what's this one? -2, 8, because I got to go 4 away and keep it the same level. Everybody cool? Now you will notice that this one gets much skinnier, doesn't it? It's a skinny happy parabola, which in North America is what everybody is seeking to be. Skinny and happy. I personally do not believe that. Because to be happy, you should be able to do whatever the hell you want. If you want to scarf down a pizza, you scarf down a pizza, damn it. And if you want to wake up at 3 in the afternoon and then watch TV all day, you do that. But you don't get to complain. That's my only rule. You don't get to wonder why you're not skinny when you wake up at 3 in the afternoon and scarf down 5 pizzas. That's my only rule. What's different here? If this was gone and this was gone, what would it be? It'd be this boring old regular one, yeah? But there's a -4, so what's going to happen? My vertex has to go where? Down 4. So I know my vertex is at 0, -4, right? Now you're smart kids. When there was a 2, I went over x and I went up a times x squared. Do you think anything changes here? No. If I go over x, what do I go up? Half of x squared. So, if I go over 1, I should go up 1, right? Except I multiply by a half, so how far do I go? I only go up a half. Is that fun to graph? No, that sucks. If I go over 2, how far up should I go? 4, but not 4 because there's an A. I go up 2. So if I go over 2, what am I at? 2, and I should go up 4, but I'm only going up half of that, so what is it? 2. So what's that point right there? 2, -2. What's this point right here? -2, -2. Then, do I want to go up 3? No, because 3 would get us 9, and half of 9 is a pain to graph. If I go over 4, how far up should I go? 8. Why 8, Henry? 4 squared is 16, and then I multiply by half. So I'm going to go over 4, all the way out here to 4, and I'm going to go up 8. 4, 4. What does that make this one? How far am I from the axis of symmetry? 4. So how far does this have to be? 4. So that makes this -4 and 4. And please notice that the fraction flattens the parabola. A whole number skinnies up the parabola. Everybody good? All right. You attempt this one. Label it with 5 points. The vertex and the first 2 on either side. Go. here we go. Let's stay cool. Let's work through this, right? It's the first time you're seeing it, so it's not going to be easy. But trust me, you pick it up very quickly. What's the vertex? 2, 6. Why? -2. So we do the opposite of what we see. Plus 6. Everybody cool? All right, so let's start with that. 1, 2, up 6. Doesn't matter if we actually put the little knots in it because we're going to label it as 2, 6. Yeah? Is it a happy parabola or a sad parabola? Why is it sad? Because it's negative. Now, normally I should go right one and up the square root of that, yeah? Or the square of that, yes? But there's a 3 there, so I'm going to go right one and down the square times what? 3. So what is 1 to the right of 2? 3. What is 1 down? Because it's 1 squared. 1 times 3? 3. So I'm going to go down 3. What is that point? 3, 3. I move 1 to the right and down 3. So what is this point automatically? Has to have the same y value, and it has to be how far away? How far away? 2 away. So it is 1. What's the next point? What is 2 to the right of 2? 4. All of you can count. Excellent. That's what I'm trying to say. No. Excellent. You can all count. Again. Extraordinary would also work. So at 4. Yes? And how far down should I go? I should go down 4 because I went 2, and I should go down the square of 2, which is 4, but there's a 3 there, so how far am I going really? 12, because 2 squared is 4, and then I have to triple it. So what is 12 down from 6? -6. 4, -6. What is this point automatically? 4 away, 0, and the y stays the same. Yo. Yes? No, dude, I went 1 to the right. So I go down the square of 1, which is 1. But it's 3 times bigger now, so I go down 3. There is all of the info. You already know it. We've written it elsewhere. But if you want to have it all in one place, there it is. It's also on the video. You can get it later. The reason I'm stressing that you could get it later is because you're going to work up to page 103. It's 203 right now. I would like to do one more of these with you before I let you go. So that is why I'm suggesting you could get this later on. And yet everybody is still writing. So, okay, I'll wait. It's cool. Rajveer. Can I what? Oh, sure. Yeah, you're right. That looks bad. Let's try... Ah! It's actually the ink that I use that's poor. Let's try a blue highlighter. Oh, yeah, there we go. It's positive Q, so it's what you see. Better? Awesome. And you know what? Let's do Mrs. Bad Crumble a solid, and let's put one of her shape of the day clouds around it. Because we love Mrs. Bad Crumble. Sadly, that joke is rapidly running out of steam because all the Mrs. Bad Crumbles are retiring, and now everybody that teaches elementary school is like 25. It's crazy. I walk into an elementary school, and I think that I'm walking into you people volunteering there because you 16-year-olds look like 25-year-olds to old farts like me. True dat. Every one of you could pass for an adult right now if you changed your clothes. The only way that gives you away is your clothes. That's the only reason I would know any of you are under 21. Only your clothes. Because I am that much older than you people now. When I was 22 and a half and I started teaching, the kids all thought the only reason they knew I was a teacher is I wore a shirt and tie and grew a beard. So I would look like a grown-up. When I did my student teaching on the first day, I had no shirt and tie and I had no beard. And the kid's like, who's that weird new guy in the back taking notes? Huh? Yeah, no shirt. Yeah. And I wore a dog collar too, so they'd really be scared. I don't want to hear your review of that, Aaron. Because when I said I wore a dog collar so that they'd be scared, you went, oh yeah. Maybe I should change my Halloween costume for tomorrow. Oh no is right, Crystal. Oh no. All right, let's go. Let's go. What's the vertex? What is it? -4, 1. What's the axis of symmetry? What's that magical line that will allow me to always find my x and y values? X equals what? No. X equals -4 because it goes right through the vertex, yes? What is the range? Is this a happy or a sad parabola? Sad. So it's going to be y is greater than or less than? Y is less than because it's going downwards. Less than what? 1, because it has to go downwards from 1. Does that make it a maximum or a minimum? Maximum. Maximum at -4, -1, because it's -4, 1, because it's going to go down from 1. So the highest y value I can have is 1. Everybody good? Now let's graph this bad boy. -4, 1. Where does it need to go? Somebody guide the pen as if I were a Ouija board because it's Halloween. Ooh, ooh. Go left. Ooh, oh my God, it's moving, it's moving. Oh, somebody's pushing it. I'm not pushing it. I'm not pushing. Are you pushing it? Who's pushing it? It's moving. Why am I way over here? Why haven't you stopped me? Well, you were getting in the way of my joke, so I had to keep going. So shut up. All right. Now what? Up? Ooh, it's moving. Who's pushing it? -4, 1. Now what? 1 to the right to get to what? -3. I like your spooky voice, Zach. Thank you. -3. And then where do I go? Down 1? Down 7? My God. Down 3. Now I'm going to do a scary voice. Down 7? No, I'm scared because you said 7. How far do I go down? Yeah, I know. He always says 7. Down how far? 3. To what number? He waited patiently for his grade 11s to do 1 minus 3. Yes, I know it's negative. I know it's -2, but so far today, in this 2 moments, I've heard -3, 7. Somewhere over here, I got something else. What is it? So it is -3, -2. Now, we know about this magical axis of symmetry, yes? That's one away, so what's this one going to be? One away, which makes it 2 away from the -3, which makes it -5, -2. And then what's the next one going to be? -2 what? How far down do I got to go? Again. Thank you, yes. Again, it is a times the x squared. If I moved 2, x squared is? X squared is? If I move 2, x squared is 4, which is? And since it's negative, I go down 12. What's 1 minus 12? Henry, step in now. They need you because we're doing that tough question of 1 minus 12. Henry, I really needed you there, man. I needed you. -2, -11. What is this automatically? If this is 2, what's this? 2. So how far have I gone? -6. And what's the y? -11. And then we graph it. And it's tall and skinny because it's got a 3. If it was 1/3, what would it be? Short and wide, like your math teacher. Okay? Not tall and skinny like Mr. DeVries, who will be your math teacher next year. Short and wide, like your math teacher this year. What? Are we all good? All right, listen up. You are doing 101, 102, and 103. Now, ladies and gentlemen, please look on 103. I've only given you one grid. Graph them both on the same grid. Okay?